So firstly, let me introduce myself. My name is Radomir Kucharski, and I have around 30 years of game development experience. Recently, mostly in managerial positions. I started making games like years ago on 8-bit computers like Commodore 64. Then I moved to the United States for 4 years when I was working at 2015 Incorporated on, among others, Medal of Honor Allied Assault. Then I was project lead on a bunch of projects. For example, Hot Wheels Track Builder for Mattel. I also was supervising production of Nightfall game that was based on a TV series from History Channel. Later, I was working on a couple of showcases for Google Tango technology, which were presented at launch, were launch titles for Zenfone Air phones and Lenovo Fab 2 Pro. Recently, I'm working as VP of production at Incuvo, where I'm focused mostly on VR games, AAA VR games, based on big IPs from other game developers, like recently this is Green Hell VR from Creepy Jar. So Incuvo is a team of very experienced developers. Incuvo previously was the background, the development background of Incuvo is mobile games, but recently we are focused on VR games, on bringing to market big IP VR games. And the question, why VR? So I believe VR is the future of gaming, and there are 3 reasons for that. Immersion. VR is way more immersive than traditional gaming platforms. The first reason for that is huge field of view. So even if we got big screen TV, if it's 60, 70, maybe 85 inches, it still does not cover the whole vision. We still can see the world around it. And with VR, we've got full coverage of what we see, and computer picture is replacing the real world completely. So that's the first reason why the immersion is so much higher in VR. The second thing is head tracking. So what we got in VR, the headset tracks its position in space and its rotation. And the computer graphics, the computer vision is changed accordingly. So what happens is when we look around, we see the picture of what's around us in the virtual world. And finally, what also increases immersion is that in VR we've got the physical controllers, so that opens new possibilities of gameplay mechanics and new possibilities, new ways of interacting with gaming. So instead of using mouse and keyboard, we can simulate natural movement of what we do in real life. This is something which cannot be done with traditional controllers like mouse, keyboard, or even gamepad. It's unfortunately not free. I mean, there is cost to it. VR games often have discomfort issues. So the major problem, there are many problems of discomfort. Firstly, the headset is heavy, it's warm, it's maybe slightly uncomfortable. There are issues with setting up the device. So generally, there are discomfort issues, but the major problem is motion sickness, which comes from the reason that what we experience in real life, our senses experience in real life, is different than what we experience in the virtual reality. Also, the major reason for motion sickness is low frame rate and latency. So it's very important to have the games in virtual reality in the highest possible frame rate and lowest latency. There is new waves of VR headsets, the standalone headsets. The small revolution started with Oculus Quest, and those address most of those issues like problems with setting up of the device, with the device being heavy, the device being expensive, because Oculus Quest is like $250 or $300, and you don't need any additional equipment. It's standalone, it just works by itself. There is, however, still the problem with frame rate. And for example, since on traditional game platforms like PC or consoles, 50-60 frames per second is pretty standard, with 25 to 30 still acceptable. Not so in VR. We need to have a flat 72 frames per second at least to have a comfortable experience. So that's pretty demanding by itself. So we still need to remember that Oculus Quest, the standalone headset, is more or less a mobile phone. So it's very limited in performance, and squeezing 72 frames per second from such a device is very difficult. And we also need to understand that the picture is generated twice, for left and the right eye, and at highest and very high resolution, because we need to have high resolution to keep high pixel density to cover the huge field of view. There are also other problems, like as I said before, with what our senses note versus what really happens in virtual world. And there is a bunch of techniques that can fix that issues, but I would like to focus on performance today. So as I said, Oculus Quest, even the most recent version, the second one, is pretty limited. It's basically a Samsung S20 mobile phone. So it really is a challenge to bring AAA games from PC, from flat platforms, to Oculus Quest and have them run with the 72 frames per second and generated twice for both eyes. Incuvo has great experience with delivering PC gaming or console games, AAA titles to Oculus Quest. We ported 3 games. The first one was Layers of Fear, and while this may sound like an easy task because Layers of Fear was mostly an indoor game. It was the whole game was taking part in an artist mansion, and it was mostly just walking around the house. So that sounds like something fairly easy to optimize and port to Oculus Quest. Not really, because what happened is the whole house was changing during the gameplay. It was dynamic. So we couldn't use a lot of those techniques which would generally be used to optimize a game. Like for example, we couldn't use light probes because the house was not only changing in the way it looked like, but it also was changing in the general room's layout. So the rooms were moved around and we couldn't use light probes to optimize lighting. The other game, the second one we ported to Oculus Quest, was even more challenging because what Oculus is not great for is a lot of translucent or transparent polygons. So what happened is we had to make all of those for the environment, which is generally woods. Blair Witch was taking part mostly in dense, lush foliage, lush woods, and that was very difficult to port into Oculus Quest. So the third project we ported to Meta Quest was even higher challenge or even more difficult to port, because not only is it dense jungle, but also it is an open world game. So our version on Meta Quest is so-called open world. It's not that open as the PC one, but still it's pretty big. It's a pretty huge game for MetaQuest. So how did we do that? How did we bring such a big PC title to Oculus Quest? Obviously, we had to optimize heavily, and we started with poly count, with geometry. The budget limit on Oculus Quest is around 100,000 to 150,000 polys on screen at once, and this is pretty low poly by today's standard. So we had to aggressively cut down the geometry, also smartly use the LODs. The second thing we had to address was lighting. With optimization, the less is better. I mean, the less of things happens on screen in the game, the better for the performance. And we had to use static lights where possible. Dynamic lights have to be used only if absolutely necessary, if there is no other way to have lighting in the game, in the level. And if dynamic objects are present, it's preferable to use global illumination and baked into the light probes. As I said, we couldn't do that in layers of field, so it's not always a feasible option. And in that case, dynamic lights are possible, but preferably only vertex lighting. And again, the less the better, so it's best to have only one light per object. So we should have the lights spread sparsely, so not more than one light affects geometry, a model. Also, what we had to do is most likely we have to turn off dynamic shadows at all. Shaders. Again, less is better. So we want to have as simple shaders as possible with preferably no PBR, no normal maps, generally old school approach how shaders were done like 15 or 20 years ago. Post-processing is a big no-no, so the best way to do post-processing is not do it at all, because full screen effects basically kill performance on Oculus Quest. It cannot handle so much fill rate. The other big no-no is alpha geometry. Translucent materials are also very problematic on Oculus Quest because, again, fill rate is killing the performance of MetaQuest. That was especially painful when we were building Blair Witch, because Blair Witch is a lot of translucent geometry overlapping. This is again a big problem because with overlapping geometry, the fill rate is even bigger problem than normally. So the best thing to do is not use alpha channel at all or alpha materials at all. Instead, you can use 1-bit materials, 1-bit mask. That's fairly okay, as long as it's not too much of it. So it's better to replace translucent stuff with non-translucent geometry, if possible. Again, less is better because it's about draw calls this time. So it makes sense to limit number of draw calls by limiting number of unique materials. You can use atlases, preferably one material per model, except for trees where we want to have separate materials for masked polygons, like leaves on a separate 1-bit mask material and trunk on non-translucent material. Also, batching of the objects helps a lot, because then we've got one material and one draw call for a lot of models at once. As far as level design goes, you want to have the old school corridor arena layout to limit visibility. This is how Green Hell is done. Even though it kind of looks like open world, it is not really. I mean, its areas are split and separated by steep rocks, so that we can use as much occlusion culling as possible. If that's not enough to have high frame rate, then we would limit the draw distance with fog. There's one silver bullet or like magic technique that really helped us at the end of production of Green Hell, because there's something which is called asynchronous space warp, and Green Hell was actually the first game to use asynchronous space warp on Quest, and it seriously helped us to deliver such a great looking game, since the technique literally doubles the frame rate from 36 to 72 frames per second with very little processing cost. It's automatic, it's enabled without almost any additional effort from developers. So how does it work? Asynchronous space warp generates extrapolated frames from previous frames generated by the VR application. So what happens is every second frame is synthetic and it's generated automatically, and it only takes like 30% of overhead or cost of processing. It's a bit like asynchronous time warp, which is also a technique used in VR, in Oculus Quest. However, asynchronous time warp only takes into account the angle, the rotation of the headset, while asynchronous space warp takes into account all the movement which happens in the virtual world. So how do you implement it? Well, Green Hell was done in Unity, and you need VULKAN API to use asynchronous space warp. What you also need is a plugin from Oculus, universal render pipeline, materials, supporting motion vectors. There is a bunch of problems though, because as always, nothing's free. So there are some issues with how asynchronous space warp works. And the first problem is that asynchronous space warp cannot handle well very dynamic movement with high contrast and or flashing strobe light. This is pretty obvious because asynchronous space warp tracks directional movement, not fast changes in color or brightness. Also, transparent objects cause artifacts. The way asynchronous space warp works is by creating motion vector map, and this map is 2D, and actually it may be lower resolution than the actual picture. So what happens is when we have translucency, and the 2D motion vector just does not know what polygons should be taken into account, because those polygons can move in different directions. So asynchronous space warp can only track movement of one of those, and it's not always right. Also, fast-moving objects which are close to the camera are also causing artifacts. And the other problem with asynchronous space warp is that it increases RAM usage. So that may be a problem on such limited platform as Oculus Quest. And finally, Unity UI objects don't support motion vectors. So you need to implement some kind of workaround to have properly displayed UI, which is always some kind of problem in asynchronous space warp because UI generally is translucent. And again, all the issues with translucency happen with UI. So we need to carefully design the game, art and mechanics to work around the disadvantages of asynchronous space warp, but I believe it's still worth it because considering all that, Green Hell on Quest looks great. It would be impossible to have such a huge game with so much open spaces and so much foliage, so much dense jungle without asynchronous space warp. So we are really happy that we could cooperate with OCULUS, with Meta on the technology, and we are actually the very first developer who brought game with asynchronous space warp to Meta Quest. Right? I hope that was pretty interesting and was worth your time. If there are any questions, I'll be happy to answer them. However, please keep in mind I'm not a technical person, so if very detailed programming questions are present, I probably will have to refer to a programmer at Incuvo.
So if you have any questions, please stand up and come here on the stage and grab a microphone yeah, feel free to ask questions.
No questions? Yeah, go ahead.
I'm on stage for free. How wonderful. Hi, I'm Basia Nasiorowska. I have big interest in virtual reality since 2015. Even registered a company called Neo VR AR and never sold a thing. So my interest is in your presentation that you said you're putting all the money on VR. And now with the new topic, metaverse, could you maybe give at least a sentence or two on how is this going to be related from your perspective?
Well, I believe metaverse will make VR even more mainstream, or generally mainstream. So with increased number of users, money will come after it. But I believe that at this point already we are past the breaking point, and the number of MetaQuest devices on the market is already big enough to generate handsome benefits, profits for developers. No more questions? Yeah, go ahead.
So I was wondering whether the decision about using asynchronous space warp was obvious for you from the beginning of the implementation, or does it come further in the development?
No. Asynchronous space warp is something that we learned about almost at the end of the development, and it actually was a huge gamble or a pretty big risk to invest the developer's time into implementing it. At the stage it was, because it was completely unproven, it was never tested. We were the testers of the technology. We were the ones who worked with OCULUS and told them how some of the things, or asked them why some of the things do not work the way we expected, what to do with it. So yeah, it was risky. It was a risky decision at the end of the production cycle, but I believe it paid off handsomely. So we are really happy we made that gamble. Good
Great.
question.
Thank you.
Thanks. Okay, all right. Thank you very much.
Okay, so please guys remember about the awards gala. It starts at 7 o'clock. Please be there and join us and have fun.